Cool, so I'm gonna start quickly. I'm Roze. I'm French, sorry. Both of us, the both talk are from French guys. I'm sorry for your ears. But I'll try to do my best. I'm working for Inviqa. I'm software engineer. I'm basically working with PHP and Symfony for quite many years now. I'm working on some applications, including Microservices one, for about a year, which is in production. We're working almost well. So we had big troubles, and then basically we had troubles again with tolerance of problems. So basically when we start doing microservices, we have problems. So yeah, that's lovely, but we have problems. So basically I will try to be quite quick, half an hour, because we have 2 talks. I'm gonna start with quickly present the idea between the microservices, and then what are the problems, and what are the solutions in terms of fault tolerance. So maybe that's why this meetup is so crowded tonight. That's basically the Google Trends of the microservices term. That's something which is extremely trendy. That's a really nice keyword at the moment. That's actually an old idea. Before it was known as SOA, which is like service-oriented architecture. The idea is basically to be able to decouple our applications, our project between different applications. You may know that already, but it's the main idea. So in the story, everything starts with our business application. That's this box. That's something that we usually have just one box, just one project that will basically deliver some features. So we can take an example of a web app. It can be a simple Symfony application using Twig, whatever, just one big application, one big code repository containing one simple application that we will deploy and use and develop always on the same one. That's basically, I like food, right? So we will have some food reference around. Everybody has spaghetti in their slides now, so I have to put one. So basically the idea of the monolith, what we call the monolith, is basically when we have this single application. So when we start to work on an application we can do things nice, but the time goes and basically we will start to put things together, and every part of our code is literally extremely coupled. And we have something which is like that, a spaghetti, that's nice, that's kind of working because we can eat it, but basically there is no way to be able to grow faster and to know what's going on in the application. Somebody which will arrive on this big monolith won't know anything about the internals of the applications. And that's the main problem. Because we're good, we're doing BDD, TDD, we have a monolith which is quite well decoupled. So that's basically our application with 4 different features. So we may have a code which is not so coupled, but still which is in the same application. That's basically where we're going to the pizza. So instead, we can work quite well on this thing as long as we have a small team, we don't have too many features, so we can still be around the pizza and eat the different slices. That's basically how we have decoupled application inside this decoupled feature inside a single one. But when the time goes again and our business grows, our application grows, that's still a pain to be able to manage everything. That's the idea of our monolith that starts, even if we are actually doing really good practices, if we are having a quite well code, it starts to, at some point when the team grows, the application grows, to be unmaintainable at this point. And that's where microservices are useful. So basically if we take these 4 features, we can have, for instance, just the front-end stuff, that can be a Twig application, just the Twig layer with few controllers, something that will manage our user account, for instance, something that will integrate with GitHub, and something that will build some images. Just an example, for instance, if we have a Docker continuous integration pipeline, something, we can build Docker images, etc., etc. That's actually an example from the application I'm working on that is based on microservices. How we will scale that? We will literally just copy the application in some different servers. All the different developers will have the entire application and work on the entire application. That's how we will do stuff. And at some point, we will have big troubles because we will have massive conflicts. We will have some change that will interfere with other developers' code, etc., etc. And basically, the monolith at some point costs a lot in terms of maintenance because we cannot introduce new features before. We need to do a lot of refactoring before introducing new features. That's the cost, the main cost of monolith. An important point is that the monolith costs a lot only in the long run. That's an extremely important point. I may repeat it. It's don't start by doing microservices. We should start with a monolith, then a monolith which is will have features which are really well decoupled, and then at some point, if we have troubles with that, we move to the microservices. Here's a microservices architecture. We take our different features and we literally do different projects with them. And then the developers can literally have different copies. We will have different teams working on different services, isolated teams, and then we can hopefully introduce proper workflow between services and help the way of growing the architecture. That's the idea. The interesting point in terms of scaling, that can be team scaling, that can actually be performance scaling, is that we can scale them differently. That's one of the main points. And then, so that can be cakes, but that can be sweets. It's literally the idea of little small that can work together, but are literally not coupled, except using HTTP messages or something like that. And if we take the same example, here we go, we have the different applications that are reflecting by our different features. Does it make sense so far? The idea is so simple, right? The problem is, the microservices actually introduce a huge complexity, but is really more flexible. And this complexity, we need to really be careful about it. So we will go more in details actually quickly the different points that we need to care about when we're studying microservices. But this is literally something that, and why this complexity we don't want this complexity at the beginning when we start a project. We want the monolith. That's really an important point to me because we started with a microservices architecture for this given project, and that was something horrible. Then we went back to the monolith and then we split again. And that worked. So literally, why this complexity is that instead of our just one request, so that's a client that will talk to the user interface, instead of having just one request, it can be an HTTP request, that's the example, instead of having just one, we will have literally many requests between different services. We don't really literally know the order, so for instance, in order to build the Docker image, we will have this user interface talking to the account feature to get the user account to be sure the user is logged in. And then we will talk to the builder that will talk to the GitHub integration, that will talk to GitHub, etc. So we will have complexity in the architecture and in the way that we need to ensure that everything is working well. That's the main challenge, actually. Because we can have, if we have a problem here, that will impact everything. So basically, we can do that, so we can try it. The only problem is this one. That can be your colleague, that can be actually your another team that will say, wow, that can be yourself. You will start to do that, and then just have big troubles because it's just a pain to maintain and a bigger pain than the monolith. That's the main point. Actually, I may focus more on the pain than the benefits of microservices.
Really selling it.
But that's really nice. So the key points, quite quickly, to me, there's 4 different key points. The organization, so that's the organization of team and of the applications. Second key point is the deployment pipeline. We need to be able to deploy quite quickly a new service or an existing service, extremely quickly. We need to have fault tolerance because we multiply the applications, we multiply the source of problems. that can be the network, that can be just bug, can be many different sources of problem. And we need to be able to monitor and debug. Literally, if we cannot monitor properly our different services, or debug when we have a problem, if we cannot actually know which request at the beginning triggers the error at some point between two services, we won't never able to to have proper architecture and proper application running well. That's one of the main problems. So in terms of organization, there is the organization in the team, and I really encourage you to have a look to the Spotify squads. So Spotify is like the music company. They're using Symfony quite a lot on really large scale, and they introduce some squads, like just the way of structuring teams. So literally we're doing microservices too, and each team is like composed of everybody which knows that given feature. So that's at the same time the UX, the UI, the product owner, and the developers. Like small team of between like 5 and 10 people that will actually know like all the different kind of people that we need to create the software, everything in one given team. It's not a team of backend, a team of frontend, etc. They created like beautiful, really nice videos about how they are doing stuff. But that's a key point to be able to actually to introduce microservices architectures. And between teams, obviously, there is the responsibility boundaries. That's why you shouldn't start by the microservices, because you need to be able to identify the different boundaries between the different services. That's something that we may not know at the beginning, and we actually don't know at all at the beginning. The communication and the shared goals, it's like between team again. If you have like different team managing services that are going in completely different directions, that won't never work. But that's a challenge. That's quite easy to manage like one team of 10 people to go on the same path. If you have 4 teams of 4 people, that might be more complex. The deployment pipeline, we need to be able to have the continuous delivery. It's literally to be able, you have many services relying on different services, you need to be able to deploy some fix, some new feature quickly, and you may introduce many different services at one given point. You may want to create a new service, and you need to be able to deploy it without having to wait for 2 weeks or months for the DevOps team to be able to set up a server. That's why I call delivery as a service, basically. The team can also change the technical side themselves. If you want to introduce a Redis, if you want to introduce a cache layer on the service, well, the team just have to be able to do by themselves. To be honest, there's many tools around. There is like all the platform SH, there's the continuous pipe.io, there's a lot of stuff, a lot of tools that allows you to do that. And basically most of them will be based on Docker, because it's quite easy to just run containers and deploy them. And new services like creating within hours or less. For tolerance, hey, the interesting bit we will focus on. So there's three ways of managing errors. The first one is like you create a perfect software. That's an option. I won't be able to do that. The second one is up. Basically, you can hope that everything will be alright. That's most of our cases, to be honest. And the second, the last one, which is to me the good one, is embracing faults. It's literally, we will have bugs, we will have some clients that will do crazy stuff that we didn't imagine. So we need to be able to recover from problems, from errors, because we will let them. There is the fault tolerance on two layers, at least the architecture side, where you host your different application. For instance, there is like all this Kubernetes stuff. If you know a bit around the Docker community, it's like be able to run something, a container somewhere, and if the server dies, this orchestration tool will be able to restart the container somewhere else.
Well, I was going to ask, how do you do your fault tolerance thing? Do you have a bundle you created that will check and then go to another server, or using...
On the architecture layer,
yeah.
Well, basically, no, I'm interested more in the application layer. To me, the architecture layer is basically, you have so many, especially when you are doing Docker, so we are doing Docker in production with Kubernetes, and that's working pretty well. You have just a lot of machines, and then you have an orchestration layer that says, okay, right, I cannot run this container anymore on this server, it will run it somewhere else. Just on the architecture side. After, there's the application side, which is basically you are talking to any other service, you're talking to an external API, then you need to be sure that you will have some different use cases, some different actual scenario examples, whatever you want to call them, that will handle the problem. And that's where we will focus on. And the last one is monitoring. Again, proactive monitoring, you need to be able to health check the applications very quickly. You need to have automatic health checks. You need to have active error logging and alerting. If you have something wrong going on, you need to be able to know that. So there's a lot of stuff. There's Neuralink, there's Sysdig, there's a Sentry, there's a lot of tools. If you want to more names, we can talk about it later. But that's literally one thing that you need to have, else you won't be able to identify the problems. And the last one is debugging after incident, being able to trace the different requests between services to know what's going on and what happened during this problem. That's scary, right? So again, literally organization, deployment, pipeline, fault tolerance, monitoring, and debugging. If you have them, just go. And then literally, we can start doing microservices. So let's do it. Let's do it on the fault tolerance side. I don't know if you have some extremely quick question regarding everything else than fault tolerance. Everything's clear, nice. So fault tolerance. Basically, we are focusing on Symfony and PHP applications. So I will present tolerance, which is a PHP library, an open source one. You can have the source code here and the documentation here. So that's a set of tools that we will be able to use to put in our application some different behaviors that will be able to quickly recover from problems. The first component I will present to you is the operations component. That's something that will define operations that we're doing in our code and then be able to wrap them into some different behaviors that will handle the problems. So if we start with something that may fail, that will fail, like for instance, I have a client, it's a PHP client, and I get the last comment for a given post, for instance. That's an example of what can happen. So there's the client coming here, the user interface will ask the account again, the request is green, the request is okay, and then the user interface will ask the builder service, and then the builder service will ask the account, everything's okay, and then the builder will ask the GitHub integration, that will ask actually GitHub, that's this beautiful cloud. But something is going wrong. Something is not good. That can be on the GitHub side, that can be on our side. We don't really know on this builder side, for instance. And if we do not handle problems, it will literally be in red for the whole path. So basically the client would say, okay, that's not working. And we will have a beautiful blank page or an error page. That's not what we want, basically. So what we can do with tolerance is to wrap that call into an operation. So there's different types of operation. That's the simplest one, the callback. So it's literally, you have your callback here, and you just run your code inside this little callback. You wrap your code into that. Once you have that, what you have to do is just take an operation runner and run the operation and you have your comments. That sounds simple. And then what we can do is literally starting to add some behaviors regarding to the errors based on these operation runners. So the first bit is that may fail, let's retry it. Often, and that's actually the first problem I had, is some network problems. We had different services on different clusters, and we had some network problems. And just retry it, on specific error codes that was solving actually many of our troubles. So literally what we can do is create a retry operation runner that will decorate our callback operation runner, and literally just say, okay, right, you have this waiting strategy between the different calls. That's the one which is based on the exponential back-off strategy, which is literally waiting 1 second, then 3, then 6. That's usually milliseconds, not seconds, else you will have troubles. And literally we just retry until there's this count limit at 10. We retry it 10 times. And that will probably solve some problems. Hopefully. But then, it may not happen, it may not solve the problems. So what we should do is have this fallback strategy. So for instance, if we have this comments example, we may just want to display the article if we are in a blog with different comments. We may just display the article, and then instead of this beautiful error page, just an empty list of comments. That's the minimal service basically. It's we want to give something to the user, even if it's the degraded mode. So basically what we can do again is to decorate the operation runner with a fallback operation runner, with basically some result factory. So everything is behind interfaces, there's all these default classes. This one is a static result factory. So you would say, if there's something wrong, if there's an exception, basically, you can actually inject some exception detectors, so you can catch your own specific exceptions. But you will say, I will just return here an empty array for the comments. And here we go. You are tolerant to the fact that your comment services may be down. So basically, so here's our request. Instead of having everything red, we can just have this one, so that's yellow. So just say, we don't really know what happened, but there's something wrong, but you still have something. Yep.
Or something like having functionality that sleeps and re-execute the command after some time. But this can also lead to asking the DevOps team to start maximizing the execution times or things like this. Is it really?
I definitely agree with you. And there's this one, which is basically the rate limiting one. So there's this other operation runner that can rate limit the inbound or the outbound of different operations. So that's extremely useful for this case. It's you don't want to kill yourself, or you don't want to allow a client to kill yourself. Most of the time that's this one. So basically what we can do, these operations, can again decorate the basic operation runner that will know how to run your basic operation. So in our example, that's a callback. And we can say, okay, right, we have, so that's actually another component of tolerance, the rate limiting stuff. So we have different strategy, including the leaky bucket, which is just saying my maximum rate of different operations is that given amount. Here it's the 10 operation per second. Quite readable. And basically we have a storage that just be able to store something. There's an in-memory one, there's a Redis one, and there's another one that I don't remember which one. A MySQL one, a Doctrine one. And basically doing that, we will be able to sleep between the different operations or simply reject them. So that's I think that's answered the question.
Can I also ask a question? Is it possible to combine those runners? So for example, try 5 times, if it doesn't work, then do something else?
Yeah, definitely. Basically, because it's based on decoration, you can decorate one and decorate another. And decorate another. Yep. And I think that the last one in the examples, that's the buffered one. That's a quite useful one. So most of the time, sometimes actually, you want to do stuff, you want to track business related metrics, So for instance, just put in our Elasticsearch, oh, there is an order, or there is something. Everything which is related to analytics, most of the time, you may not want to actually do them now. You may not want to spend the 10 milliseconds like querying the Elasticsearch or anything. You don't want to do that now, but you want to do it later. But actually in your code, what you can just do is like just run the operation, just run that thing. But later, what you can do is like so put them in the buffer and run them later. And that later should be after the request. And we will see, so that sounds not really useful here. With the Symfony integration, that's really more useful, because everything is done for you. And yeah, because we're in the Symfony meetup, we need to talk about Symfony. So that's a PHP, everything is just PHP, so we can even use that in Laravel. I have nothing against. But there is a Symfony bridge, which is literally just a bundle. So here we go, you can just add your bundle instance in your app kernel, and you're ready. The first feature of it is, because we love YAML in the Symfony community, we can create operation runners using YAML. Yeah, that's nice, right? So literally, just the preferred one, the callback ones, the ritual ones, etc. The preferred runner again. So basically, if you know the kernel, the terminate event in Symfony, if you don't know, that's just an event that is called after the response is sent to the client. Most of the time. It actually depends. Some cases of your Apache setup or anything, it won't work. But most of the time, this is some code that you can run after the request is sent to the client. That means that all the processing time you spent, well, the processing time you spend after this event, the client won't see that. So you can even spend a second, and the client will only see your 100 milliseconds of processing. Make sense? Mm-hmm. Cool. So basically what you can do is like every time you need to run to push some metrics, just do that, just wrap them in some operation and run them using a buffered runner. And the Symfony bridge will automatically know that you have a buffered runner, and then it will call the run operation stuff. I don't remember exactly the name of the method, but it will run the operation that are in the buffered runner and the kernel the terminate event. And that's the fun stuff now. That's AOP, aspect-oriented programming. That's just something that is literally able to plug some stuff in your code. So basically, I love this operation stuff, but most of the time we don't want to update our code to be able to add these fault tolerance features. We may just want to like activate something and that's done. And we can actually do that with AOP. It's something that we literally run commands after or before you code on some functions, on some objects. And there is something amazing done by Jonathan Smith, GMS, which is like an AOP bundle that will allow you to plug stuff in your different objects, different services, for instance. So actually, you have to activate it in the YAML configuration because that costs a bit of time sometimes. Because literally it's creating proxies of your classes all the time. But actually only when you compile the DIC. So basically so let's say we have our HTTP client of our command, let's keep the same example. And to be able to have it like fault tolerant, the only thing we can do with AOP is just add this tag. Just say, okay, right, let's add tag tolerance operation wrapper. Wrap which method? So to keep the same example, get last comments. And which runner will I use to run this function? So basically, you just have to configure the runner, the YAML, or your own service using your own factory, and put that tag and you're done. And that's all. And you can have the fallback, you can have the retry, etc., etc. There is also an operation runner that allows to actually send this operation to a queue, and it will be able to like well, with a bit of configuration for the pooling of the messages, we'll be able to run the operation after in some other process. And that's that. And you can use actually your service as usual. Because of these proxies, it will implement the same interfaces, it will extend the same classes. You can just do nothing else than putting this tag. And voila. You can go to the gym now. No, so yeah, basically this is an interesting feature if you don't want to introduce or to couple your code to this fault tolerant stuff. That's all for the operation component. No questions?
Yes, one question. Because in that callback function, well, it didn't return anything, it didn't do anything. So what action indicates it failed? Is it like an exception being thrown?
An exception, yeah.
Okay.
So by default, it's all the exceptions. So it's literally try catch / exception. But you can actually use a different exception catcher. So if you want to be more precise on the different exceptions, if you have exceptions that are not failures in terms of operation, you can use your own exception catcher. Kind of special, like precise handling of exceptions. So quickly, the last one, and that was about fault tolerance between services. And the last one is a message profile component. I will go extremely quick, but this is the point where we want to actually trace and debug messages. So we have all these different services, yeah. So we have all these different stuff, and if there is something wrong going here or here, what the client will see is probably there is something wrong in it, or you will receive an automatic message from your Sentry or whatever saying, wow, something wrong happened. And the principle of the message profile component is to be able to link all the different requests together. So what it's literally doing is putting some message IDs in all the different messages. So here the example is only HTTP requests, where it's putting messages on IDs on HTTP requests and MQP messages and something else. The idea is extremely simple. Just activate this component using again YAML. Just say, hey, what's this peer? So you can have like application name. You can have all the different like key label stuff that you want. So you can identify after. We'll see in the different in the screenshots. And you can have storage. The storage you just need. The best way is to store in like graphs. So you will have Christoph talking about it just after, but that's basically storing all the different requests in the Neo4j, so you can have this beautiful graph and get the information quite quickly about what are the different requests caused by which ones. There is also an Elasticsearch backend, but I wouldn't recommend using it. It's not really efficient. And that's all. It's almost all you have to do. And this is basically integrated with Guzzle. So each time you will use Guzzle to send a request, it will put a message ID saying, hey, I sent this one. And the message ID can be used by the reception, by the recipient of the message, saying, we can link actually who sent what and who received what. Monolog, just like putting this request ID in the logs, you can have the logs after. You can get the logs from this tag. RabbitMQ, so it can also put putting the message identifier in all your RabbitMQ messages, MQP actually, and Symfony obviously, like when you're receiving the message, getting the ID from the headers, etc., etc. And actually, the end is this beautiful UI. So that's also open source. That's an AngularJS application with a Symfony backend, just an API, which is talking to the Neo4j backend. And what you can do is to just type a message identifier in this bar, here, and click on inspect. And you will have, so that's an example with two services talking with GitHub. And you will have this graph, so that's a simple one here, where it's literally taking all the different trees. So even if you have the message ID, this one, or this one, it will be able, because of the graph, being able to identify all different requests. And then you can actually click on the different messages, and see different details of the messages. So you will see like the containers, well, all the different contexts you put in the current peer configuration. And you can actually see how long the request took, from who sent it, who received it, etc., etc. And you can see the logs. I don't have any screenshots, but you can, because of the tag, the monologue tag, you can actually get the logs of this given message ID, and you have all the logs for this given message, just here. And voila, and basically with that you can debug. So that's just an optional UI. You could use it, you can use something else, so like literally up to you. But it helps to be able to, when we have a problem, it helps to see the entire picture of what happened for this given message, basically. And I think you can go back to the gym again. Like literally, we have time well, it is extremely simple when we have this trouble to see all the different logs and all the different problems. That's the key point when you're in microservices. And voilà. Thank you. Do you have questions?
I wonder if I just go right back to the very beginning with a basic question. You've got a Symfony application and a load of services in there, but they're all running in the same app. What's the first step to start moving some of those to run independently? Are you just injecting Guzzle into the service and having it make HTTP requests, or is there something else you do to get it?
So the question was, we have an application, a monolith, and we want to basically extract the different services. How you do that? There's many different ways. What I would do is literally communicate over HTTP messages most of the time. There is this other option, which is communicating over queues or something. I'm not fond of this idea because you cannot really abstract that communication, that queuing system. I would like to have just an HTTP request. If you need some queuing for doing some asynchronous stuff, each service will have its own queue. So I didn't talk so much about the basics of microservices, but literally each service should have its own persistent layer, so you won't share a database. To me, you won't share the same queuing system, but literally just HTTP messages. And why HTTP messages? Like, you can have actually whatever technology is able to understand HTTP messages, or at least most of them. And the key point of microservices too, if we're going back in that, is like you can have each service should be a small one that you can replace in few, let's say, weeks maximum. In 2, 3, 4 weeks maximum, you can actually remove it and create it in another technology. That's one of the key points of the microservices is to use the right technology for the right service, basically. And just having this common communication language, which is most of the time HTTP.
Well, let's say, since now we talk about failing to perform a request, but let's say the failure is on the recipient, so we try again. If we know, if we somehow detect that the failure is on the instance that, let's say, produce the request, is there any way to transfer it to another instance?
Oh, you mean like identifying after that, for instance, this server is like the source of all the troubles?
Yes, but move the original, move the transaction requested to another, so it's called to another one.
Oh yeah, okay, I got it. So there is no thing for that. So basically, what you're kind of talking about is like circuit breakers. There is nothing intolerant for that. There is some actually really good PHP libraries of doing that do that. We could integrate them in some operation runners quite easily, to be honest, because that's literally just an interface to implement. But yeah, that's a really good point. That maybe something we should have a look more. It's like introducing circuit breaker in it. And regarding the way of like analyzing a given server, for instance, which is the source of the troubles. Well, actually, because we're storing everything in graphs, Christophe may be able to answer a bit better, but we could actually do some recommendations around, oh, look at this container or this pod, if we're in the Kubernetes world. Actually, this server is like the source of 80% of the failed error, the failed messages. You should have a look. That's more about recommendations after. But yeah, that's definitely doable.
Do you tend to use one service for the security layer? Like, if you're looking at an API, is that the standard protocol to keep one layer coming in and then other services behind it, or?
Yeah, usually I would say that you almost only need one public API. So you can only have just one API. What I'm doing is like one public API that you can use GWT, for instance, for authentication, or even OAuth if you really need like something big. And then between the different services, you can just use client certificate. So HTTP you can have the client certificate in each service that will allow to sign the HTTPS request to the other service, and that's done, basically. Or even like if you can have your architecture that have these different services on the private subnets of your network, that's even better.
Okay. What about latency issues? Have you noticed that much?
Regarding HTTPS and client certificate?
Just generally like communicating between different machines as opposed to processing all on one machine?
Yeah, that definitely introduced like some problems where you need to retry sometimes. Yeah. Yeah, I have no magic solution for it, but yeah, distributing computing is like you cannot be sure that your message will arrive. When you start to introduce different layers like that, you have an increase of the potential source of problems. Yeah, but you need to be able to handle them.
Yeah, fair enough. Right.
We'll try it.
I still go back to the beginning of the talk when you were talking about being able to redeploy at any given time. Yes, the question I was asking earlier was more about the configuration side of it. So on your services, if for some reason a service is down and you need to redeploy using another host, how do you spread the host name of that new machine to the other services?
Oh,
in PHP?
yeah, okay. Yeah, literally, you should have looked to Kubernetes and to containers and orchestration layers. So basically what you can do is you will always use a DNS name that you can, so DNS name can belong to switch around. But if you have IP failovers or elastic IPs, if you're in the AWS world, you can switch quite easily between different machines. If you're in the classical world, if you're literally in some Docker clusters, you will be able to have this load balancer and this orchestration layer that will literally knows, okay, this container moved. And you should literally go to this path, I think. Cool. Thank you very much.